Lighting accounts for the largest electrical expense in modern buildings. This course will show you how occupancy sensors and photocells can maximize energy savings while enhancing building and occupant performance. As you follow along with this presentation, you'll learn how integrating this technology will result in an immediate and dramatic savings in energy expenses. After completing this module, you will be able to do the following. 1. Explain how changing energy codes and standards influence sales of occupancy sensors. 2. Describe the technologies used by occupancy sensors, which applications these technologies suit best, and how these contribute to energy savings. 3. Define daylighting and explain how photocells contribute to energy savings. Sensors are not a new technology, but their adoption and implementation is critical to today's design strategies. Major trends driving the greater adoption of sensors include building codes and standards, LEED certifications, legislation and government trends, and interest groups initiatives. Reducing energy consumption benefits the public both economically and environmentally. As a result, the government is interested in promoting energy efficiency. Today, energy codes set stringent standards for lighting power, including mandatory requirements for lighting controls. These charts illustrate the rapid change that standards and codes are undergoing from state to state as public awareness and government legislation increase. How are occupancy sensors used to meet lighting codes and lighting legislation? Energy codes for commercial buildings often require automatic shutoff. Occupancy sensors help buildings meet this requirement by recognizing when rooms are empty and automatically turning off the lights. Ideal applications for sensors include smaller enclosed spaces, such as restrooms or supply closets, spaces that operate on an unpredictable schedule, such as employee break rooms, and spaces that are only intermittently occupied, such as conference rooms. There are three basic types of occupancy sensors: passive infrared, ultrasonic, and acoustic. No matter which type of sensor technology is selected, the basic idea behind the use of an occupancy sensor is similar: identify when a room is vacant to turn off the lights. Click each of the tabs here to learn more about each technology. Passive infrared or PIR sensors are well suited to smaller enclosed spaces and confined outdoor spaces. PIR sensors are line-of-sight devices, so the space must allow the sensor to have a line of sight to the primary task activity. Because the cutoff of the field of view can be adjusted in the field, PIR is also well suited to applications requiring a limited field of view, such as corridors and warehouse aisles. Ultrasonic sensors emit high-frequency sound waves into the space, which are reflected back to the sensor. If the sensor detects a change in frequency in these waves, a change in occupancy status is detected. Ultrasonic sensors can see around obstacles and are more sensitive than PIR sensors, but the detection range cannot be adjusted. Ultrasonic sensors are most sensitive to people walking directly towards and away from the sensor. Acoustic sensors use a microphone to listen for sounds caused by typical motion. These sensors use advanced technology to distinguish between white noise and sharp variations in the captured sound wave that would indicate occupancy. In addition to the three types of occupancy sensors, there are dual technology sensors that combine more than one sensor type in a single device. For example, acoustic detection is not a standalone detection method. It is combined with PIR detection to produce the most reliable method of detection available. The result is called a passive dual technology sensor. Dual technology is ideally suited to open indoor spaces, spaces with obstacles that block a clear line of sight, and spaces requiring greater sensitivity and reliability. Typical applications for passive dual technology include open offices, private offices, lavatories, classrooms, and conference rooms. How much electricity can you save by installing occupancy sensors? A lot. To see for yourself just how much energy you can save in a retrofit project, use an occupancy data logger to track the exact amount. As you can see in the example here, you can see exactly when a room is occupied, how long the room stays occupied, and when the lights have been left on in an unoccupied room. Daylighting is the illumination of a building using natural light. In addition to the potential for saving electricity, incorporating sunlight into a building's lighting plan has been shown to have multiple positive effects. Buildings with natural lighting report increased retail sales, as well as more satisfied and more productive employees. Natural light in schools has been shown to increase student learning and improve reading and math scores. Daylight harvesting relies on natural sunlight as a useful light source. According to various studies and estimates, 40 to 70% energy savings is obtainable in common office spaces and classrooms that use daylight harvesting. However, natural light in itself does not save energy. Energy saving occurs by incorporating lighting controls to implement what is called a daylight harvesting strategy. A typical daylight harvesting system harvests daylight by reducing or turning off electric lighting in response to incoming daylight measured by a device called a photosensor. The result is less electric lighting being used during operating hours and therefore lowering energy consumption and cost. Photosensors nearest to the window detect that more light is necessary when sunlight entering the room is no longer sufficient. The lights nearest to the window automatically increase their output to provide the necessary illumination. Daylight typically enters a building in one of two ways: from the side, in the case of windows, or from above, in the case of skylights. Before installing photosensors, you must take into account where the light appears and how it can be supplemented. Refer to each of the tabs here to learn more. Open loop placement is often synonymous with top lighting applications. Usually, only one global photosensor is required to control a large area, as shown here. This is ideal for large open areas where people are moving through the area or where precise light levels are not important, such as warehouses, retail stores, and atriums. North-facing applications are the simplest in which to place photosensors, as they're not exposed to direct sunlight. The sensors can be placed in a broad region, usually 6 to 12 feet from the window. In a space with a south-facing exposure, photosensor placement should be towards the north side of the primary daylight zone, far enough from windows to avoid direct sunlight. Discover if sunlight is blocked by a window treatment or awning. When the exposure faces either east or west, placement should be towards the south side of the space and far enough from windows to avoid direct sunlight. Again, check to see if sunlight is blocked by a window treatment or awning. Indirect lighting applications pose particular challenges for photosensors. Ceiling-mounted closed-loop sensors can be overwhelmed by direct exposure, not only to sunlight, but also electric lighting, such as the uplight component of suspended direct-indirect fixtures. For this type of application, a fixture-mounted sensor would be recommended. As you followed along with this presentation, you've learned some of the ways lighting energy is wasted. Lights are left on in vacant spaces and after working hours. Buildings are overlit and they do not make use of daylight. But you've also learned how you can realize a dramatic improvement in energy costs. You should now be able to 1. Explain how changing energy codes and standards influence sales of occupancy sensors. 2. Describe the technologies used by occupancy sensors, which applications these technologies suit best, and how these contribute to energy savings. 3. Define daylighting and explain how photocells contribute to energy savings. Congratulations for completing this module.